So today we're going to be looking at correlation. It's part of the bigger branch of statistics. However, many people just tend to consider it as its own thing, but generally it's part of the topic statistics. So correlation deals with the relationships between paired values of an experiment. So we are going to see how much of this is going to make sense, but usually we have like two. We have an experiment, maybe a variable, another variable, then we are comparing them, the relationship. Are they correlating or not correlating? It's going to make more sense in a few. Then we are going to plot all the values on a scatter diagram. It's also going to make sense in a few, but I can even talk about it now. So you just draw your graph, have an x-axis, depending on the variables, a y-axis, and you plot your points randomly. After plotting the points, you get a line of best fit, and you'll try to split these points into two. So you have, that's why it's called a scatter diagram. Now this scatter diagram shows one of the following relationships. It either shows a positive correlation, like now here you see this line is positive, but however it could also be like this, negative correlation, like when something is decreasing, or it could show no correlation, like something that's almost straight, though that's rare. So for separately ranked paired values, so we are going to have to always use this formula, Spearman's rank correlation coefficient. We have this mu is, I don't know if this is not mu, this is equals to 1 minus 6 summation of d squared out of n into n squared minus 1. So this one is actually in the logbook. You may not have to cram it, but still mastering it and understanding what these different things mean, it's going to help you. So n is representing the number of paired values, and d is the difference in the ranks of the paired values. So in a few minutes we are all going to understand what this means. Now the value of this value that you get, as we saw from above from the other formula of the Spearman rank correlation, the value you get, you can grade it. So from 0 to 0.2, because the values we are saying they range from -1 to 1. So from 0 to 0.2, that is a very low correlation, like a very low. Then 0.2 to 0.4, that is low. 0.4 to 0.6, that's moderate. And now usually in many questions they ask you to comment, so you should be able to know that is it very high, is it high. So there's usually a mark at the end for commenting on the correlation. And the value of this is not p, it's a Greek symbol, this. So the value of p can be interpreted using a significance test for correlation. Now the value of this value, maybe because we said it ranges from -1 to 1, so it can be -0.3 and can range till 1. Now the value you get its magnitude. Magnitude means like you ignore the sign, meaning even if I had -0.2, I would ignore and this take it as 0.2. So the magnitude of like whatever answer you get is significant at either 1% or 5% if the calculated value exceeds the value in the tables, otherwise it is insignificant. Now this may not make sense, but let me show you what this means, though we shall see it more as we work out. So now the value you get, when you get its magnitude, you come to your logbook. So here, sorry, this is not exactly how it is in the logbook, but here they use proportions. They use 0.2, 0.1, 0.05. Now this 0.005 is 5%. This 0.01 is 1%. So if you've worked out your answer, your value of mu, let me get here a marker. If you calculate your value of mu, for example, let me use this. You get your value of mu. Now the value of mu you get its magnitude. After getting its magnitude, you want to check if it's significant, maybe at the 5% level. If you want to check if it's significant at the 5% level, you now ask yourself, in the question, how many pairs did I have? Usually we are going to see what that means. Now that's the n. Maybe you realize that you have 5 pairs. So you add this and you have 5 pairs. And now you look at this value. This is what we are meaning here. Now let's go back and I show you what I meant. Okay, so now we say the value of this is significant at either 1% or 5% if the calculated value exceeds the value in the tables. So it's significant because when we were in the tables, we had something like 0.05 We had other numbers here, but this is now for in your logbook it will show 5%, also 1%. Then you come here on the column for n. N is for number of pairs. Let's say you have 5 pairs or 6 pairs. Now you come and get the value in this column at this point. Now if the value you calculated exceeds the value in the tables, that value is significant. Hope that makes sense. Now if the value is less than this, it's not significant at that level. So that's the thing, and it usually has 1 or 2 marks, just commenting. So this was just to remind us that when you're plotting, you plot x, y, the variable. It can be a positive correlation, it can be a negative correlation, it can be no correlation. And now also another thing I wanted us to quote: many learners fear these numbers because they don't know how to do the line of best fit. Yet the line of best fit actually usually carries very few marks in this concept, so you can actually get most of the marks before you even do the line of best fit. Just get your graph and plot all your points, then you now try to divide them. But otherwise, even if you didn't do the line of best fit, but you've labeled your axes, you get marks for labeling the axes, you get marks for all these points. Make sure you have a title, make sure you have a scale, you'd have most of the marks. So even if you didn't do a very correct line of best fit, you'd still have most of the marks on this question. So it shouldn't be a worry that. And also, as you do the line of best fit, you're just simply trying to divide the plots into equally into 2. That usually should be the goal. So maybe here you have 1, 2, 3, even inside you have 1, 2, 3, you draw it around there. Okay, so now let's start looking at examples. So now this is our first example. The table below shows scores of students in mathematics. So you are spelling mathematics and English tests. And then the question says calculate the rank correlation coefficient for the students' performance in the 2 subjects. So I think I should have actually drawn lines, but let's do it. So we have math, then the marks are 72, 65, 82, 54, 32, 74. I think I've written very big figures. Let me clear this. Should write something much smaller so that it fits. So okay, we have math, then this is 72, 65, 82, 54, 32, 74, 40, then 53. So that's the first column, math. Now after the first column, remember we are calling this rank correlation coefficient. So of course we are going to be ranking somewhere. Now we are going to put this column rank for math, RM, rank for math. Then I go to English. I'm going to show you how we rank. So we have 58, we have 50, trying to make sure they're in line. Then we have 86, then we have 35, then we have 76, 43, 40, and then 60. Then now I put also here the rank for English. So now this is the first thing we are going to do. So just imagine these are like marks of students in your class. Now we want to start ranking the marks. Now the ranking, it can either be in ascending or descending order, and usually you choose one. Like if you're doing ascending order, everywhere you should rank in ascending order. If you're doing descending order, everywhere should be in descending order. However, usually you choose it on what's simpler for you, and I think since many people rank these marks from the highest, so that's what we are going to take. So now in this class you should look through keenly and now see from these marks. We can actually even start doing it from here because it may be more clear here. In mathematics, you look through this mathematics column and you see, okay, what's the highest mark? Roughly here I can see it's 82. So this is number 1. Then I still move through. I see this is number 2. Like this is the highest mark, followed by the 74. So be number 2 in this class for mathematics. Then I move, this would be number 3. I hope this is making sense. So just ranking. Then I look for any other mark. After 72. What's the next highest mark? It's this. So this is number 4. Then we look for the next mark. This is number 5. This is number 6. And this is number 7. So we've ranked now we have number 8. So We can now write them here the way we've ranked them. So this is number 3, this is number 4, this is number 1, this is number 5, number 8, 2, 7, and then 6. So all of them have been ranked properly. Then now we also come here. I said we maintain, so we've been ranking in descending order. Even here we're going to rank in descending order. But if someone had ranked in ascending order here, they would also rank here in ascending order. So it depends on what's easier for you. For some people, ranking in ascending order could be easier. So now here you go for English, you look what's the highest mark, you look through everything. I see this is the highest mark. Then I see what's the next mark. This should be number 2. You look through from this. I think we go to this is number 3. From this would be number 4. Then this would be number 5. This would be number 6. This would be number 7. This would be number 8. Then now we come and write them here. So we have 4, 5, 1, 8, 2, 6, 7, 3. Now when you reach this point, we're going to add a column called D. Now this D is the difference between the ranks here and the ranks here. So this D is going to be RM. I'm just writing here for the sake, but usually just write D because everyone will understand what you mean by D. So this is the difference between the ranks for this column and the ranks for this column. So I'm going to start subtracting. 3 minus 4, you get negative 1. 4 minus 5, you get negative 1. 1 minus 1, we get 0. 5 minus 8, we get negative 3. 8 minus 2, we get 6. 2 minus 6, we get negative 4. 7 minus 7, we get 0. 6 minus 3, we get 6 minus 3, get 3. Then now we have to add a column for D squared. So actually this is one of the simplest steps. We are going to just keep squaring. So when you square, this is 1, this is 1, this is 0, becomes 9, becomes 36, this becomes 16, this becomes 0, this becomes 9. So when you look through, you realize we didn't have any actual importance for this D. We just needed to get the D squared. That's why we are finding this so that we can get D squared. Now, however, it's important for you to find this D because it can be a big clue in showing you whether you've ranked these values properly, because when you rank these values properly, the sum of your D should be 0. So here you actually, if you try to do it properly, you will see that it will be 0 because this is 6 minus 4, you get 2. This 2 will clear out, maybe this 2, this 3 will go away. So you get 0. If you try adding D, the sum of the D should be 0. So this is not important, but it just guides to show that you've ranked your values properly. So always you can do it as a checker. Now the summation of D squared, we're going to add everything here. So this is just a matter of putting these values into the calculator. I get this is 72. Now why we are getting this, we have to get our formula, and I told you this formula is in the logbook, so you don't have to cram it, but if you can, it's to your own advantage. So now we substitute 1 minus 6 times, because this is 6 times summation of D squared times 72, out of n is the number of pairs. So you count 1, 2, 3, 4, 5, 6, 7, 8. There are 8 pairs. This will be 8 times 8 squared minus 1. So you put this is 1 minus 432 out of, that would be 504. Get your answer as 0.1429 for decimal places. So this would be the answer you get. And now remember, we said you can check if it's significant at 5%. Now this value, the good thing is already positive, but even if it was negative, you'd ignore the negative because we said we take the magnitude. So to check if it's significant, you see how many pairs do we have here? We have 8 pairs. And this is the value we have. We want to check if it's significant at 5%. So let me pause and look for the graph. Alright, so now we are here. So we said we had 8 pairs. So we come here to 8 and we want to check the significance at 5%. So you come, you check here, and we say this is our value we got from the magnitude of this. Now we said it's significant if the calculated value exceeds the value in the tables. So now here, look at the value we have in the tables and look at the value we have from our calculation. So the value we have in our calculation is less than the value in the table, so it's insignificant at 5%. That's the comment you give. It's insignificant at 5%. So because you've gotten the 8 pairs, you've come at this. But however, you should get this page in your logbook, go for you to have 5% depending, and it will be 1%. So that's how you check. Yeah, and if the question had asked you to plot, you would just draw, you would have this plot. Maybe one axis would have math, another axis would have English. It's not a must for any of these to start from 0. So at the end, I think I'll give us a clue about how we go about getting the scale for this. So you plot this, you get maybe 72, you come here, look for 72 wherever it is, then come on this axis, look for 58, that's the point. So you plot both. So then you come here for the second one, 65, look for 65 on math, then go to 50. So that's how you get the second point. So you plot all of them, and most of the marks are on the axis, on the title, on the scale, and on these points. So you shouldn't fear that you're going to lose marks because of your line of best fit. However, you should also learn, you should know how to do it. Now then you have this second one. Teacher gave 2 tests in chemistry. 5 students were graded as follows. So this also should be simple. So I think I'm just going to do the grading. Then I think everyone can be able to, I'm going to put here the final answer you get. So this is test 2. Then this is rank 2. So we're going to write this test is A, B, C, D, E, then B, A, C, D, E. So we're going to write this one, A, B, C, D, E, and you're going to call this 1, 2, 3, 4, 5. However, I've told you someone can choose to rank in descending order, but if they follow it properly, they will still have the same answer at the end. So here, we're going to give this one 1, I'm going to give him 2, 3, 4, and 5. Same here, we look for A, give it 1, look for B, give it 2, look for C, give it 3, for D, 4, this, give it 5. So still you'd come here, get your D. This would be -1, this would be 1, this would be 0, 0, 0. Come for D squared. I told you here you can always confirm if you've ranked properly by getting the summation of D. And for our case, it's 0, so it proves get 1 here, get 1 here. This is all 0. So your summation of D squared is 2. So you come to your formula. 6 summation of D squared out of n into n squared minus 1. So this is 1 minus 6 times 2. Look how many pairs do we have? We have 5 pairs of 5 times 5 squared minus 1. So most of this is just how properly you're going to use your calculator. And you get here 0.9. Now here the question has said comment on your results. Remember, it gave us a range. Now there's a very high correlation. Very high because it's 0.9. So that's why I told you should get, though it shouldn't be, if it's not easy for you to master it, you can estimate because this is 0.9. So if it's like still 0.8, you can call it very high. Then around 0.5, you can call it moderately high. However, it would be good if you get the correct. So let's now look at, I think, one more question, and then the rest will be the exercise. So here we have the awards to 8 schools by 8 judges, 8 schools by judges X and Y in a quiz contest were. So these are the marks we have. These are the awards we have. So we're going to come and write Judge X. So this is 50, 56, 50, 56, 60. Now I think if you could pause this video and try it out, you would see why we need to do this example. Yeah, you would see, because here we have values that resemble each other, like we have values that are the same as we are ranking. Previously we've been having all values being different. So here we have 52, here we have 60, here we have 75, here we have 66, here we have 54, here we have 70, then this is 60 and 68. So this is what we have. Now we are going to start ranking here, though like last time we are going to use this since it's more neat. So we look for what is the highest. Now here we have to be careful because you see there are very many repeated values. We have a 60 here, we have a 60 here. We have now the rule of ranking is you have to always ensure that this 1, 2, 3, there are 8. So your last has to be 8. So the total of all your rankings has to be like not the total doesn't have to be 8, but they should be 8 numbers. Like you should have all of them going up to number 8. So now let's see what I'm saying. So we have this is 60. So we look through and see what's the highest. I think the highest is 60. But however, 60 is appearing twice. So if we were to rank this, we would maybe say this is 1 and this is 2. But however, now we have to get the average. So actually, let me write here 1, 2, 3, 4, 5, 6, 7, 8. So these two are taking up these first two numbers, 1 and 2. But we can't call this person 1 and call this one 2. Because just imagine it was you and you had the same mark as someone. Now they want to maybe say they are the first and you're the second. So now these people would have to attain the same position. How do we do that? We say 1 plus 2. Because there are two people who have that position, divide by 2. So this would be 3 out of 2, which is 1.5. So this one is 1.5, that's his position. That's also the position of this one. It's also 1.5. But however, here on our list, the numbers 1 and 2 have been taken up. We cannot rank anyone as number 2 because these two people, one was supposed to be number 1, one was supposed to be number 2, but now they have combined to one number. So we now have to move to number 3. But now when we reach number 3, this one would have been maybe number 3 and this one would have been number 4. And now we have another 56 and have been number 6. So then we would have had 3, 4, 5 actually. This is 1, 2, 3, 4, 5. So we have these 3 people having the same mark or having the same award. So you cannot say this one should be number 3, this one should be number 4. All of them would not be happy because they have the same position. So what do? We say 3 plus 4 plus 5 divided by their number, which is 3. So here we are going to get, I think we're going to get 12 divided by 3, we get 4. So all of them, we are going to give them a position of 4. All of them are going to give them a position. So we are doing this because we have to be fair. However, now when we come here on this list, the numbers 3, 4, and 5 are taken. Hope this makes sense. The numbers 3, 4, and 5 have been taken. So we cannot award them to any other person because remember how we got these 4 was from getting their average. So those numbers have been taken. We can't give them to anyone else. So now we continue. So our next numbering should be number 6. Now we look. So this is number 654. We give him number 6. Can give this one number 7 and this one number 8. Hope this is making sense. Then now we move to the judge Y column. So still on the judge Y column, you look for who is the highest performing judge. Here I think it's the highest award. Here I think it's 1. 75 is 1. So I think 75 is 1. Then now we look for who is number 2. I think it should be 68. So actually 68 is not the number. So actually realize that 68 is not the number 2. We have 70. So this would be the number 2. This would be the number 2. Then now see we can go to 68 as number 3. Then we can come to 66 as number 4. Now we come to 60 and we want to give them number 5. However, when you look at 60, there are two 60s. So one of these 60s should be number 5, another one should be number 6. So I hope you're getting that right now. So we have 5 and 6. These two numbers have been taken. So 5 and 6, we get their average. 5 plus 6 divided by 2, we get 5.5. We give them one position. However, 5 and 6 have been taken. So now the next person, you have to give them number 7. So this is 54. We give them number 7, and this is number 8. So we can now just come and write our ranks here. Now this is where it becomes very important to slow down and work slowly. But the good thing is, even if you realize you've made an error, you can always correct it as long as you're keen in the paper or wherever you are. So we have this is 8, this is 5.5, It is 1, then 4, then 7, then 2, 5.5, and 3. Then now we go to the difference between them. So we are going to say we're subtracting. So we're going to subtract 1.5 minus 8, we get negative 6.5. 4 minus 5.5, we get negative 1.5. 8 minus 1, we get 7. Gets 0 here. Negative 5.5. And here we get 5. Here we'll get negative 1.5, and here we'll get 3. So still you can test this by adding and it will give you 0. However, that's not even needed. It's just to help show you whether you've made any obvious mistake with your ranking. So here we come and now square each of these. So we get 42.25. Here we get 2.25. Then 49, 0, 30.25. Then 25, 2.25, then 9. So now we get the summation of this squared. This is going to be 160. So now quote your formula. 6 summation of this squared out of n into n squared minus 1. This would be 1 minus 6 times 160 out of how many pairs do we have? We have 8 pairs. So we end up having, I'm just going to quote the final answer, negative 0.8. So this is your answer. This is the answer you get. So I hope this makes sense. But still, if you're going to check if it's significant, you use the magnitude. Okay, now here, usually the other questions that can follow, they can ask you to plot and draw a line of best fit. They can even ask you use the lines of best fit to predict or determine the value of x. So now here we have, let's say these are the two, you have a table, let's say. These are the tables. You have a table of x values, you have a table of y values. So this is how it is. So usually you get the value of x, come here, look for it, get the corresponding value of y, make a plot. Repeat for all the plots. However, the title is going to carry a mark. Always when you're drawing your axes, make sure they have these arrows. Don't just assume this arrow and this arrow, and then after you calibrate. Don't just use the lines of the graph paper. So you calibrate your things properly. Then you have a scale for both the vertical and the horizontal axis. Set it properly, and 1 centimeter. Don't use this abbreviation, right? Vertical scale, horizontal scale. 1 centimeter represents, and then 1 centimeter represents. So ideally, then after you label your axis, so ideally most of the marks are going to be here. This, the axis, the title, the scale, then each of these points is going to have a mark. So by the time you plot the line of best fit, already most of the marks have been given, so you shouldn't fear. But however, as you try to do your line of best fit, try to make sure you're splitting the plotted points, because here, see, we had 1, 2, 3, 4, 5. So you here with this line, you try and split them, 3 this side, 2 this side. That's okay, because some other person would have actually gone through one of the points and have two. Maybe someone can still come like this, maybe force it to, but that wouldn't be very even. Or someone would bring it close here and take it, so that the point is just having something more accurate, not very accurate, but still you will get the mark. Then now here they can ask you the question using the lines of best fit to predict or determine the value of x when given y. So maybe they say, after you've plotted, they say find the value of x if y was 20. That means you come here to your axis and look for y where y is 20. You dot to the graph, you pull, and then you read off this value of x, and then you give it, and you get the mark. And for these questions that have graphs, put your answers below the graph. Don't put your answers below the graph. So that marks the end of the topic of correlations. Yep, and now this is the exercise. So I'm going to just display it as you see the answers. I will actually not put the answers, just follow through with the answer there. So maybe to say something small about this question specifically. Now here, plotting the scatter diagram, this is okay. Comment the relationship you comment. Is it a positive correlation, a negative correlation? You do the line of best fit and use it to find, this is what we're talking about, the UNABE mark. So you just go to one of the axes. Let's say you plotted it like this. This is MOX, and then UNABE. Now they are saying UNABE mark for students who scored in MOX. So you come here for MOX, put that value, look for a line of best fit, find the value for the UNABE marks, then you quote it. Now here, this is where I want to lean on the equation of a line in form of y is equals to bx plus alpha. Now this question, they want you to form an equation in this form, but you have here what x is and what y is. So you form simultaneous equations. That's what you see. So I come here and maybe I choose, because I see here, what did I choose? I chose this. Choose any two pairs of your choice. Then this, I chose these two pairs for me. Then I form these two equations. Hope it's making sense, because this is y is equals to, this wasn't represents beta. So this is y is equals to beta x. So I just come, so I just substitute here, because here the value of x is 58. You see me putting here 58. The value of y for the adjacent is 61. I put here 61. So I have two equations. When I solve them simultaneously, I get the value of x as, I get the value of beta as 1 and the value of alpha as 3. So that's how I substitute this into this formula, and I have that. So then this and that. Thank you for following to the end. That marks the end of